All right, so we are going to move on to balancing redox reactions. It can seem a little hard. There's quite a few steps that you must follow. So let's see if I can find that. Of course not. All right, give me a minute. I'll pull it back up. All right, let us try that again. What is really different about redox reactions, since they involve the movement of electrons, you have to account for this in your balanced equation. So there's a couple of different ways we're going to go with the half reaction method. So like I said, they can be tricky to balance unless you have a systematic approach to it. If you don't, then you're probably going to be in trouble. Another thing is that these are often written with just the net ionics showing. So sometimes they look a little bit different than our regular complete molecular balanced equations look. All right, so we're going to start off with this reaction of MnO4 minus plus I minus goes to Mn2 plus iodine. All right, so that's going to be our reaction, and we're going to balance it. So the first thing that I need to do is I need to figure out what's being oxidized and what's being reduced. The easy one is iodine. It's going from a -1 to a 0. So that means the iodine is being oxidized. And then the MnO4 over here, it's a +7. Over here, it's just a +2. So my Mn is being reduced. So at this point, I separate them into two half reactions. So I tend to write my reduction half reactions first. We said that involves the Mn manganese. So that would be MnO4 minus going to Mn2 plus. And I can already tell I've written that too big. So let me try to rewrite that. MnO4 minus going to Mn2 plus. Also, if you did not watch the video, this is going to look really foreign to you. If you did, you should have a little bit of an idea of what I'm doing. And then my oxidation half reaction was my iodine ion going to my iodine compound. So those are my two half reactions. I will tell you from experience, be sure that you keep up with your charges. I tend to drop these charges as I'm rewriting things, and then that makes it really hard to balance. You don't realize whether you're balanced or you're not balanced. Okay, so the first thing that we're going to do is we're going to balance 4 atoms. So not oxygen or not hydrogen at this point, other than hydrogen, other than oxygen. Okay, so if I look at my reduction half, I have 1 Mn, and over here I have 1 Mn. So it is already good. So I'm just going to write it again. It's good as far as being balanced with regards to elements other than hydrogen or oxygen. But if I look at my oxidation half, I have 1 iodine here and 2 here. So I'm going to balance that. So I'll put a 2, and that will give me an I2 here. All right, so at this point, we need to look at those two, and we need to add water to any half reaction if it needs oxygen. So in other words, if you look here, this reactant side has 4 oxygen, so I need to add 4 water molecules. That is how you're going to get your oxygen that you need. Now, my oxidation half dealing with my iodine, that doesn't need any oxygen. It already has oxygen on it, or it doesn't have any oxygen, so I don't have to worry about doing that. All right, so at this point, that leaves the hydrogens now unbalanced. So now I'm going to add hydrogen ions to balance that off. So I'm going to have to scooch mine up a little bit. All right, so we had our reduction half at this point was my MnO4 minus and Mn2 plus, and I added 4 water for the oxygen. So now that gets me off. So I have to add 4 times 2, 8H plus. My oxidation half, which was my iodine, since I didn't have to add water, it ends up being a lot less work. So I don't need to add any hydrogen to that. My next step is that I need to balance for charge. So not only do my elements have to be equal, but also my charge has to be equal. So if I look on this side right here, at this point, I have a +8 and a -1. So I have a total +7. Over here, I have a +2. So obviously those are not balanced. So I have to add electrons to the side that I need to balance my charge on. In other words, +2 I have here, +7, so I need to add 5 electrons. The electrons are going to be added on the reactant side for the reduction half, and then they'll be added on the product side for the oxidation half, because reduction, something is having to gain electrons, so they should be on the reactant side. Oxidation, getting rid of some electrons, so they should be on the product side. So here I have a -2 on my product side, it's neutral, so I need to add 2 electrons. Okay, so that's where I am at this point. All right, so I think I kind of wrote it. That should have all been written right there. You also probably written in the right place since you were not erasing. So at this point, I need my electrons to cancel out. So I have 5 electrons in one, and I have 2 electrons in the other. So kind of like doing the closest denominator, the smallest number both of those would go into would be 10. So I'm going to multiply everything here by 2 and everything on this one by 5. Okay, so that's going to be my next step that I'm going to do here. So when I do that, I have 5 times 2 would be 10. I think I am actually down here. 10 electrons. 2 times 8 would be 16H plus 2 MnO4 minus gives me 2 Mn2 plus 8 water. Okay. Now I need to go with my other one. I'm going to multiply everything here by 5. So 5 times 2 is 10. So 10 iodine gives me 5 I2s plus 10 electrons. And let me go back a minute. This right here, this step is your balanced half reaction. So if I ask you for your balanced half reactions, this would be your balanced half reduction. This would be your balanced half oxidation. Right through here. That is before you multiply by a number to get your electrons equal. That is your balanced half reactions, because I will ask you for those. And if you give me the step where you have multiplied the electrons, then it will be wrong. Also, if you try to save time by doing a lot of scratch out and I ask for your half reaction and then you scratch over them to work through the rest, I will not count them right. I can't tell if that's what you want me to look at or what you don't want me to look at. All right, so at this point, we want to cancel out everything that we can. If it's on a reactant side of one and a product side of the other one, then I can cancel it out. So the obvious one that we have to cancel out is our 10 electrons. A lot of times you'll be able to cancel out some hydrogen ions on some water, but in this case, we can't because we did not have to add that to our iodine, our oxidation half reaction. So that's all I could cancel out. And now I put it back together. So 16H plus 2MnO4 minus. And then I come down here plus 10I minus. And that gives me, and now I need to put all of my products. 2Mn2 plus 8H2O plus 5 I2s. All right, if we do a quick check, 2 times 2 is a positive 4. Over here, I have a lot more going on. I have 16 minus 2 minus 10 will give me a positive 4. So they are both correct. None of this is part of the reaction. I was just doing those for teaching purposes. So you should not write all of that. Whoops. All right, 16. I think I had 16 and this was 2. So we checked to make sure it was balanced with regard to charge and also balanced with regard to elements. I have 16 hydrogen here. 2Mn, 2Mn here, 2 times 4, 8 oxygen, 8 over here, and I have 10, this was a 10, iodine, and 5 times 2, I have 10 over here. So we checked all of our boxes and we did everything that we needed to do. All right, I'm going to work through one more of these. All right, let me go up a little bit because we don't need all that. All right, so right now we're doing things in acidic solution. Those are kind of the easier ones. That means I can have some hydrogen ions at the end and it's okay. Tomorrow we'll do them in basic solution and then that will change. All right, so just like we did, my first thing that I'm going to do is I'm going to figure out what's going on. Easiest one, chlorine. It goes from 0 to a -1. So that it is reduced. So I like to write my reduced half first. Goes to Cl minus. And then oxygen probably is the same. My sulfur, if we look over here, it is a +2. And over here, 8 plus 6. So it was oxidized. So we're going to go S2O3 2 minus goes to SO4 2 minus. All right. So I like to always start with my reduction, and how I like to do it is I like to work all the way through it and then come and work all the way through the other one. So my first thing I need to do is balance for elements. I have 2 chlorine, so I need to put a 2 here. Don't have any oxygen. I don't have any hydrogen, so I don't have to mess with all of that. Excuse me. So then the only thing I need to do is fix it for charge. So 2 times -1 is -2. So I have to put 2 electrons over here. That is my balanced half reaction. If I was asked to write my balanced half reaction, that is what I would write. All right, my second one, I'm going to come to over here. I'm going to balance my element, 2 sulfur. So I'm going to put a 2 here. Now, if we look, 2 times 4, I have 8 oxygen, and over here I just have 3, so I'm going to have to add 5 H2O. I'm going to go ahead and get this out of the way because I can tell that's not going to work. All right, and then 5 times 2, that gave me 10 hydrogen, so I'm going to add 10 H plus. And now I need to check my charge because I should have some electrons on my product side. So I have a total of -2 on my reactant side. On my product side, I have 10 minus 4, so a total of +6. So I am going to have to add 8 electrons. When I add a -8 to that, I end up with a -2 also on my product side. So that would be my balanced half reaction for my oxidation half. So our next step we're going to do is we need to do something to get rid of the electrons. So I have 8 electrons here, 2 here. I can easily get my 2 to 8 by multiplying this by 4. So that's what I'm going to do. 4 times 2 is 8 electrons plus 4 Cl2 gives me 8 Cl minus. Okay. Once again, this is not my balanced half reaction. Before I multiplied it, that's my balanced half reaction. Okay. Now at this point, we're going to see what cancels out. So this is what I'm talking about. If I ask you for your balanced half reactions and you don't rewrite them and just start canceling things out on them, I will not count it right because I will think you don't think that that's right and you're canceling it out. So on most of the work, I try to give you a place to write each of these so you won't accidentally do that. All right, so we got to get rid of our electrons. So I'm going to cancel out. Oops, I didn't mean to do that. Because I don't have room to rewrite. I don't have a place to write my answers. You should have written your answers. This one as your balanced half reduction. This one as your balanced half oxidation. Get rid of my 8 electrons. And once again, that's all that I can get rid of because that chlorine didn't have any water or hydrogens added to it. So now I just have to put everything back together. 5H2O plus S2O3 minus 2 plus 4Cl2 gives me 8Cl minus plus 2SO4 minus 2 plus 10 H plus. All right, let's do a quick charge check. I have a total of -2 over here. And on this side, I have 10 minus 8 from here. 2 times -2 is -4. So when I do all of that, I end up with a -2. So my charges are good. And then I'm going to do a quick check on my elements. 8, 4, 8, and those are also good. So this would be my balanced redox reaction. That should also be then written on your spot, on your answer spot. All right, let's see. I'm going to try to find one that might be a little bit tougher. Let's just jump down and do number 3. Number 3 is a little bit hard. I'm telling you that it's a disproportionation reaction, which means a redox reaction in which a species is being simultaneously, I can't say that word, or at the same times reduced and oxidized. And what I mean by that is if we look at this, my bromine is 0 and it goes to -1. So it's being reduced and then it's 0 going to a +5. So it's also being oxidized. So I'm going to get you started. Your reduction half, we said, is when my bromine goes to my bromide. And then your oxidation half, same thing, bromine. That's what makes it a disproportionation reaction going to your BrO3 minus. That's your oxidation. All right, pause the video and give it a try and then start it back up when you can. All right, so let's work through this one. Once again, I'm gonna do my reduction half. It's gonna be a pretty easy one. I have 2 bromine, so I'm gonna put a 2 here. 2 times -1 gives me a -2, so that means I have to have 2 electrons written here. That is my balanced half reduction reaction if you are asked for that. Now I'm gonna go to my next one. Once again, 2 bromine and only 1 here, so I'm gonna put a 2 here. 2 times 3, that gave me 6 oxygen, so that means I'm gonna have to add six waters. Once again, I can tell that's gonna already be in my way. 6 times 2, 12 hydrogens, so I'm gonna come over here and add my 12 hydrogen here. And now what I need to do is my charges, which should be in my product side. On my reactant side, everything is neutral. On my product side, I have 12 minus 2 for a total of 10, a positive 10. So that means I'm going to have to add 10 electrons. That is my balanced half reaction that I would need to write down if I'm asked for that. So these would be your balanced half reactions. Now at this point, I need to figure out what I need to do to continue on. I have 10 electrons here. I have 2 here. So I need to multiply this by 5. When I do that, 10 electrons plus 5 Br2 gives me 10 bromide ions. So that's now what I'm working on. You should have already written this as your half reaction. So at this point, you should have written this as a half reaction, this as a half reaction. So this should be like what you're working on, kind of like your scratch paper. So you can cancel out here to get your final answer. If you try to save a step and you start canceling out on this step, and then you expect me to also count that as a half reaction when you've canceled out on it, I will not do that. I'm not going to know whether you think it's good, you think it's right, you don't. So let's see what we can get rid of. 10 electrons. Once again, that's going to be all because we didn't have to add water to one of them. So now I need to put them back together. And I have my 6H2O plus, and notice I have 1 bromine here and 1 here. So 6 bromine. And that's going to give me 10 bromide plus 2 BrO3 minus plus 12H plus. All right, so that's everything put back together. Now I'm going to do a quick check on my charge. Let's see where we got. All right, so when I do that, I'm neutral over here, and over here I have -10, -2, so that's -12, cancels out with a +12, so that would be my correct balanced overall equation. All right, tomorrow we're going to add one more step to it. We're going to do this in a basic instead of an acidic solution. All right, so we will be having a test on this next week, probably on Tuesday. We will not have a separate quiz on it. And I'm pretty sure I mentioned this on the last video, but you do not have to memorize the oxidation rules. I will give you access to a set of those.